Hi everyone. So for these sets of problems, a tool called GasTab is really useful. So as you remember in aerodynamics, when you're given a gamma value, Cp over Cv, like for air, for example, it's 1.4, you are able to use Mach number to find some area ratio, temperature ratio, pressure ratio of that specific location with respect to the sonic conditions. So with nozzles, for example, that's the throat. For Fano flow or Rayleigh line or Rayleigh flow, that's different, but it's still useful to know those ratios. But in those tables in that textbook, it only is for air, gamma 1.4. So with these special types of problems, where we're not just working with air. For example, we need oxidizer and fuel, and that's our mixture. That's what we're exhausting out the back of the engine. With a different gamma value, like for example, gamma equals 1.4 in this problem, then it can be really useful to have a tool that does those table reads for you based on any gamma value, and that's called GasTab. So in this problem, yes, it is a jet, it is using air, but for this one specifically, GasTab is really useful because it gives these impulse function fractions of the impulse at that location over the impulse at the sonic condition, and it can be really easy to use the impulse to find thrust, because thrust is the impulse at the inlet minus the impulse at the exit. So if we know the Mach number at the inlet and the Mach number at the exit, which we do, 3.2 and 0.9, and we also know gamma 1.4 because we know this is air, then we can use GasTab to do a table read to find out this impulse function ratio, and also just like area to area, the sonic condition ratio, and same for pressure and temperature, and that can help us find I star, which is the impulse function at the sonic condition. So it'll make way more sense when I go through it actually in GasTab. So let me uninstall GasTab really quickly, and then we can reinstall it together. Okay, so in order to install GasTab, you need to search up AIAA, Elements of Propulsion, the beginning of our textbook name, and then go to Elements of Propulsion in AIAA. Scroll down just a little bit. On the right hand side, you're going to see something called Supplemental Materials. Click on that. Then you're going to go and click on AED Sys Setup. Open that file, and then double click Setup Application. Allow it to make changes to your device. Then press OK. Wait. Okay. So let's just press that. You're not going to get that warning because I had GasTab and it was actually still open, as you can see. So let me close that. It's not letting me. Hold on. Yes, I want to close it. Okay. So then you're going to press continue. And that's just because I've used GasTab before, so I'm going to say no to all. Okay, press OK. Now it closes. Now you actually have to go through and search for it, GasTab. And it's right here. Double click it, and it's up. So now let's look at these problems and see how GasTab can be useful. So for this one, we're trying to find the Mach number. We know the gamma value, so let's put that in, 1.25. Okay. And then we also know the area over the area of the sonic condition, because it says the exit area of the nozzle is 77 times the throat area. So A over A star is 77. Put that in, press enter, press the supersonic condition, and our values update. And basically what this is doing is allowing you to do a table read at the specific gamma, at that specific area ratio, so you know all the other dependent variables based off of that. So let's say you had Mach, for example, and let's say we thought Mach is just 5. All right, see how this changes. Press enter. It's pretty similar because we only moved the Mach a little bit. So all these values are dependent on each other. The values update based on the gamma value and one other input. Now you put that in, you put the area ratio, you know Mach. That's the first part of this problem. Now the second part of this problem is finding the area of the nozzle throat. So that is going to, it gives you a clue. You need to use MFP equation. So it actually gives you the MFP, and let me put in 77 again so we can actually see the right value. MFP is this. And I actually solved for it numerically and got something quite similar, but not actually the same. I think the discrepancy in this is that it tells you that RGC is equal to this. So you can either solve for R and plug it into the MFP equation, then you solve for MFP using what they gave you, which is this knowledge, because R is in that MFP equation. So you can't just use this value because the conditions are different. So once you find MFP using the form of the equation that depends on the Mach number, MFP also has a form where it doesn't depend on Mach number, it actually depends on area. So if you know the total temperature and the total pressure and the mass flow rate, then you can solve for the area of the nozzle throat because you know MFP. So why it's useful in this problem is because thrust equals the impulse function at the inlet minus the impulse function at the outlet. So I1 minus I2. And if you input the Mach number at state 1, which is 3.2, and this is air, so it's 1.4 here, and we'll put 3.2, then we're going to get this impulse function. Now that's I1 over I star, and record that down. Now we go 0.9 because that's M2. Now we've got this, I2 over I star. Now we know thrust equals I1 minus I2. Well, what is I star? You need to solve for that. Yes, so we know that the thrust on the control volume is I out minus I in. So you can just think about this as I inlet minus I exit. Exit. So I star equals P star A star 1 plus gamma times Mach number. And Mach is going to be 1 because star is associated with the sonic condition. You know, gamma, it's 1.4. Now you just need to find P star and A star. And you can do so by using this value here to solve, because you know what A2 is. So you can find A star. They tell you A2. So now we just need to know P star. And they tell you P1. Once you find P star, A star, and then thus I star, you can find I1 and I2 and then the thrust. And that's it. I hope this video was helpful, and comment if you have any questions.